So, generative AI. It can feel pretty complex, right? But here's the thing, it's not magic. It's a technology that's actually built on 5 distinct, really powerful layers. In the next few minutes, we're going to break down that entire structure for you, from the apps you use every day, all the way down to the actual silicon it runs on. I mean, think about it. If you've ever used an app like Gemini to help you draft an email or just brainstorm a new idea, you've already interacted with this tech. But have you ever stopped to wonder what's actually going on behind that screen? What are the real building blocks that make it all possible? Well, it all comes down to this, what we call the Gen AI stack. We're going to explore these 5 interconnected layers, starting right at the top with the applications you actually touch. And then we're going to work our way all the way down to the foundational hardware that powers the whole thing. All right, so let's start at the top with the application layer. This should feel pretty familiar because this is the part of the stack that we actually see and interact with directly. A great way to think about this is like the dashboard of a car, right? You don't need to know how the engine works to actually drive it. You just interact with the steering wheel, the pedals, and the screen. The application layer is exactly that. It's the user-friendly interface that lets you control and tap into the power of the entire AI system underneath. And you're probably already using tons of applications in this layer. Think about the Gemini app on your phone, or how it's integrated right into Workspace, or even a research tool like Notebook LM. These are all perfect, everyday examples of the application layer in action. So here's the next question. What allows these applications to do more than just answer a single question? How can they tackle really complex, multi-step problems? Well, the answer to that lies in the very next layer down, the agent layer. An agent is what makes the AI proactive. So instead of just sitting there waiting for your next command, it's a piece of software that's designed to go after a goal all by itself. You give it an objective and it figures out the best steps to get there using whatever tools it has. And this really highlights a crucial difference. A model all by itself is fantastic for a single direct prompt, but an agent can handle those complicated multi-step jobs. It's the difference between asking, "What's the weather?" and saying, "Hey, plan my entire weekend trip and make sure it's based on good weather." So agents can operate on their own, using a whole bunch of different tools to make decisions without needing you to hold their hand the whole time. They can go out and research topics, troubleshoot code, or access totally different systems, basically chaining all these actions together to achieve a really complex goal. Think of them as the independent problem solvers of the AI world. Okay, so if the agent is the problem solver, what's powering its thinking, and how does it connect to everything else? That brings us even deeper into the stack, to the next 2 layers, which pretty much function as the brain and the backbone of the entire operation. And this is a perfect way to think about it. If the agent is the one out there taking action, the AI model is the intelligence. It's the cognitive engine that's actually driving all of those actions. At its core, a model is a massive algorithm that's been trained on just a staggering amount of data. And all of that training allows it to learn patterns and relationships, which is what enables it to generate new text, translate languages, and answer your most complex questions. But how does the brain, the model, connect with the problem solver, the agents? Well, that is the job of the platform layer. It acts as the backbone, the essential connective tissue that allows all these different components to work together seamlessly. So the platform provides this critical toolkit for developers. It offers APIs, which are kind of like standardized plugs that let different software talk to each other, as well as tools for deploying models and managing data. In short, it simplifies the incredibly complex job of managing all the underlying infrastructure. It's really the workshop where AI gets built and maintained. All right, we've finally reached the bottom of the stack, the infrastructure layer. This is the fundamental bedrock that everything else, the models, the platforms, the agents, and the applications is built upon. It's really easy to forget that AI isn't just some abstract code floating in the ether. It runs on real physical hardware. The infrastructure layer is that physical and software foundation. Without it, none of the other layers could even function. So what are we talking about here? We're talking about tangible hardware, like servers and specialized processors, things like GPUs and TPUs, that are designed to handle the massive calculations AI requires. It also includes all the software needed to store the models and to manage all of their training data. Okay, so we've deconstructed the entire stack, from the app on your screen all the way down to the silicone in a data center. But why is understanding all this so important, especially for people who are leading teams and making decisions? This is the key takeaway right here. Knowing how these layers fit together isn't just some technical exercise, it's a strategic necessity. It allows you to guide your teams, to make smarter decisions about technology, and to truly harness the power of AI for your own goals. So, from the foundational infrastructure all the way up to the user-friendly applications, each one of these 5 layers plays a crucial, interconnected role. They aren't separate pieces. They are a single, cohesive, and incredibly powerful system. The stack is really a map of AI as we know it today. But this field is moving so incredibly fast, which leads to a final, fascinating question. As this technology keeps evolving, what do you think the next layer is going to be?